Hello, my name is Patil. Today we will learn active filters versus passive filters. What is mean by filter? A filter is a frequency selective circuit that allows only certain band of desired frequency components of an input signal and attenuates undesired frequency components. So first, what is frequency selective circuit? So there are various types of input signals are there. In input signal, suppose we want to process some voice communication, audio communication, FM communication, or we want to analyze the data of voice. So voice has a certain range, 20 hertz to 4 kilohertz. Audio has some one range, 20 hertz to 20 kilohertz. If you want to process, analyze, communicate all this signal, we have to pass through this one block called as filter, which will reject the signal which is above 20 hertz and higher frequency, that is in audio it is 20 kilohertz, and passes the wanted signal 20 hertz to 20 kilohertz. So first is signal. There are two types of signal. One is continuous time signal and one discrete time signal. Continuous time signal is called analog signal and discrete time signal called as digital signal. So now there are types of filters depending on the continuous time signal. We will call processing of continuous time signal we call it analog filter, and processing of discrete time signal we call it digital filter. So there are number of ways to build filters. One is two ways. One is passive filter and one is active filter. So in this two of categories, passive and active, there are subcategories called as low pass filter, high pass filter, band stop filter. In band stop filter, there are also two categories: wide band stop, narrow band stop. Again, band pass filter, wide band pass filter, and narrow band pass filter. So these are the nothing, all the subcategories are there. And all pass filter means all frequency has passes, but there is in every signal there is a phase difference are there. So now in the screen we can see there are ideal filters. Uh, uh, there is a frequency versus gain. So if you talk about this low pass filter, in low pass filter this omega c is the cutoff frequency. Cutoff frequency is a single frequency where which will decide a pass band and stop band. Pass band means all required frequencies input signal is passes through the filter, and all unwanted signal is attenuates in the stop band. Same with the high pass filter. So this FC again differentiate between the stop band and pass band. So all the input signal which above omega c, that is cutoff frequency, are passes, and all the frequency below this is rejected. We can say the band stop and band stop filter. Now there are two cutoff frequencies. Okay, so in low pass and high pass filter there are only single frequency are there. So if you make a combination of low pass and high pass, we can make a band stop filter which having a two different cutoff frequencies. So below omega c1, that is fc1, all frequency are passes. Between omega c1 and omega c2 all the frequency are rejected, and again above omega c2, above cutoff frequency, all frequencies again passes. Again vice versa, it is a reverse in the band pass filter. So let's take a simple example. In the simple example, in the left side we can see in the column there is a frequency domain signals are there, and in the right side is a time domain analysis. So in the time domain, we can see there's a noisy sine wave generated. Noisy sine wave is just combination of three different frequency of three different amplitudes. It's added together and generate a noisy signal out there. So such a noisy sine wave signal passes through the low pass filter. We just observe first two frequencies will pass and the third frequency is rejected. So we can see this waveforms in the low pass filter, output of the filter circuit. Same for the high pass. If you passes the other two frequencies and reject the first frequency, we can see the high pass filter. And now if you pass same signal, if you pass through the band pass filter, then we can see that original signal is at the output of filter circuit, and this first signal, this is the signal, and this signal has to be rejected. These are nothing but a noise. It's added in the original wave, and so we have to pass through the band pass. Again, we can say the same way, we can say the band reject filter. So in band reject filter, we have attenuate the uh, sinusoidal signal and passes the noisy waveform to the band reject filter. So if you talk about the passive filter, they are designed using a resistor, capacitors, and inductors. That is the RLC network. So when you design a passive filter, so to minimize the distortion in the filter characteristics, it is desirable to use inductors with high quality factor. So in the passive filter, inductance generally used to minimize the distortion character. But when we use the inductor for lower frequency, they becomes a very bulky and the expensive. The weight is also more, and if you know that inductance are also generating some noise if you are not manufactured very properly. So there is a one disadvantage in the passive filter. Now another one disadvantage we can say, characteristics we can say in the passive filter. There's in the circuit, in the slide we can say there is a one low pass filter circuit is designed. It is using a R and C. So input is applied to the from the left hand side, output across the capacitor C. If the signal is passes through this particular in pass band, the output signal is less than that of the input signal because drop across the series element. So at a very low frequency, this capacitor provides a very high reactance because we know that Xc is equal to 1 upon 2 pi Fc. So lower frequency, this capacitance acts as a high reactance. So all input signal is passes through the R. As frequency goes on increasing, this capacitor, that reactance offered by the capacitance, is decreases, and this R and C provides is generally like a voltage divider. That means Xc upon R plus Xc. So now there is a drop across the R. So always we can say the gain always less than the unity, that is called as attenuation. So in the pass band, we never amplify the signal. In also in the pass band, in pass band, gain always is less than the input signal. Again, the output is across the capacitor. So output impedance of this particular circuit is depend on the reactance of the capacitor, and reactance of the capacitance depend on the frequency. So as frequency vary, output impedance of this particular circuit also vary. Again, if you exchange this component C and R, so it becomes the high pass filter. So this passive high pass filter offers theoretically an infinite high frequency response. Now if I exchange this C and R, so we are generating a high pass circuit. So just see that the response of the high pass filter circuit, this is the, if I draw, this is the F, and this is the, I can say gain, right? This is the gain, X, Y axis is the gain. And if you draw the practical frequency response starting from the 0, and it is continuously constant. So this is the nothing but we can say this is the FC, this is a cutoff frequency. So below this FC, all signals are attenuated, and above FC, all frequencies passes. Or so now we can see above FC, there is a at infinite frequency, this passive filter can be worked. That is called infinite high frequency response after FC. Now this particular circuit, just same low pass filter, is a different low pass filter in cascaded form. The passive filter circuits contain multiple stages. The loss in signal amplitude called attenuation can be becomes coercive. As I told you that a single RC circuit provides output signal which is less than the input, and if you connected many circuits in the same form, so at the output side we can say the output is very less than the input volt signal are there. So this is a severe in that case. So why to connect but this cascaded state? Because if you connect this different circuit in cascaded, the order of the system, order of the filter circuitry goes on increasing. Is the that previous slide is the first order system. If you connect the other three RC circuits together, is a third order system. So this is related to the rollover that's called a minus 60 dB per decade. One way of restoring or controlling this loss of signal is by using amplification through the use of active filter. So we can sort out all this disadvantage of the passive filter can be sorted away by active. So what is active filter? Means is nothing but we have to use the take help of a semiconductor component like a MOSFET, FET, BJT, and the operational amplifier. So when you talk about this active components are there, so they operated on some source, energy source. So they take energy, external energy from external power source and use it to boost or amplify the input signal. So if you take the inactive filter, if you use the operational amplifier as a one component, so it has a many one advantage that the high input impedance, low output impedance, and voltage gain determined by the resistor network within its feedback loop. So output voltage is never be less than the input signal. It's the one of the main factor if you're using the operational amplifier. So passive, as I told you in the previous slide, the passive there is a disadvantage of advantage of passive high pass filter is offers theoretically high infinite frequency response. Above FC, at infinite frequency, this particular passive high pass filter will work. But if you design this high pass filter using a active component, a semiconductor component, so frequency response is also limited because active component, that is op amp, has its own frequency response. So it cannot be operated for an infinite frequency. So its own frequency response will limit the filter high frequency signal. Active filters are generally more easier to design than passive filters. They produce a good performance characteristics, very good accuracy with a steep roll-off and low noise when used with a good circuit design. The filter amplification can also be used to either shape or alter the frequency response of the filter circuit by producing more selective output response, making the output bandwidth of the filter more narrow or even wide. Active filter using op amp has some advantage, as I told you that there is a more advantage just listed down. So it provides high input impedance, low output impedance, voltage gain determined by the resistor network within a feedback loop. Meaning of this basically, operational amplifier provides very high open loop gain. If you provide the negative feedback using a resistor network, so this particular gain of this particular circuit is decided by the external component. So that is the advantages. It again reduce the size and weight because we are not using any inductor. Increase reliability and improve performance. Simpler design than the passive filter and can realize a wider range of functions as well as provide voltage gain. So we can provide any voltage gain at the output signal. This is the main advantage. In large quantity, this cost of an IC is less than its passive counterpart. So what is the disadvantage in the active filter or op amp? Because if you are taking the help of the any active component, its active component has its own limitation are there which can be incorporated in the active filter. First is that active RC filter some disadvantage that limited bandwidth, as I told you that we cannot go at an infinite frequency range. We have to find out from the data sheet what maximum frequency this particular op amp, selected op amp, is operated. Then achievable quality factor is also limited. then require power supplies. But even if this is a disadvantage of your power supply, but the advantage is that using this power supply, we can boost the signal, amplify the signal, increase the sensitivity to variation in circuit parameters. As I told, that operational amplifier has its own limitation, its own parameters are, which is the temperature dependent, which is the power supply dependent. As power supply vary, as the temperature vary, atmospheric condition, the parameters get changed, and it may affect the filter performance. So depend on many application, as I told you that in voice, audio, FM. So this application in voice and data communication, the economic and performance advantage of active RC filter will compensate their disadvantage. Thank you.